All right, good afternoon, everyone. We are on the home stretch here, almost done with NDC Copenhagen's Developer Festival. I don't remember the exact name, but one of those things. Yes, my name is Jimmy Bogard. You can find me on Blue Sky, I guess, at jimmybogard.com. And this presentation, as well as the examples that I'll be showing, the code examples, you can find on my GitHub at github.com/jbogard. And I do have a website and a blog, but I am woefully behind in putting blog posts up there. But you can still find me there at jimmybogard.com. So my day job is a consultant. So this talk is a lot about my experiences about introducing observability and OpenTelemetry into existing applications. And so when I mean Brownfield, that term for this talk just means systems with little to no observability and maybe little to zero OpenTelemetry in place. Now, OpenTelemetry is a standard, and so I have to give the standards disclaimer, which is, people try to standardize on specific things, and observability platforms is in one of those things. And so you look at something like OpenTelemetry and say, well, that's yet another standard. So does that mean that's just like N+1 standards that we have to worry about? But luckily, that seems to not be the case with OpenTelemetry, that it seems like the industry has really rallied around OpenTelemetry as a movement. And so I felt pretty comfortable about, one, introducing it into my clients, as well as just trying to build on top of this as a whole. So I want to talk a little bit about my OpenTelemetry journey and where I sort of got introduced to OpenTelemetry as a standard, as well as OpenTelemetry being used in the systems that I was dealing with. And in particular, I first got introduced into OpenTelemetry with a client that was doing microservices, of course. And so this organization was taking an existing big monolithic system and rewriting it into a series of smaller microservices. Now, this is not a value judgment on whether that was a good idea or not, but I was there to help them build these services, try to make them maintainable, and also to try to make them sort of easy to debug in production, or at least like not on your local laptop. So the way the system was architected was we had individual services that each had their own individual MongoDB database. So I had service A, B, C, etc., all talking to their own individual database. So they're at least doing like something right with microservices. Everything had their own database. And then in order to actually use any of these services, they had Angular on top of this, so some kind of SPA that would coordinate all these different services together. And then a lot of the operations they were performing needed to coordinate or orchestrate between each of these services. And so, of course, they needed to use some kind of broker behind the scenes, some message broker. So we had RabbitMQ as the message broker to be able to shuttle messages and coordinate activities, notifications between each of these different services. This entire system was deployed on something called Cloud Foundry. Has anyone ever used this? Oh, good. It is not something I'd recommend to anyone. I've never seen it before, and I hope to never see it since. And so each of these kind of services are deployed into this ecosystem that is Cloud Foundry. And then at some point, the user has to use this. So the user was using a browser to be able to interact with all these services, but they didn't know that all these services existed. So there was nothing really exposed to the direct end user that this was some complex machinery behind the scenes to be able to orchestrate all these different services together. Now, when I showed up, everything, of course, is super easy to write and debug locally because everything's running locally, and you can see the console log messages pop up. But of course, in a cloud environment, we need something on top of that because we don't have just access to console logs. So this company was using Splunk as their single observability tool of choice. I don't know who chose it as their single one. I assume it was like the CTO on the golf course somewhere. It's like a handshake deal that this would be the only thing they're going to use. But they were using Splunk, which is a Cisco company, I guess. So this is kind of what I was introduced to, is they're building all these services, they've got all these different things going on, and me as a developer, like I can kind of understand what's going on locally, but when it comes to any other deployed environment, it looks more like this, where you have like the browser hits a page, and then like something happens, and then we just had Splunk on the other side to try to Humpty Dumpty things back together again. Which, by the way, that was the egg that fell off and he broke, and then someone has to put them back together. So that's what we were trying to do, is like how from this complex system, all these different things talking to each other, can I try to figure out what the heck is going on behind the scenes? Now, I would say one caveat here is that I don't often get to choose the observability tools. Actually, I never get to do that, because that's like these giant enterprise license agreements that you have to like have multi-year, whatever. So a lot of this talk as well is like how we deal with what we have versus this sort of ideal. And what I've often found as well is that like once observability tools have you kind of locked into their kind of mode, then they only want you to do what they're able to do. So that is just one kind of caution here, is that what Splunk wanted you to do one specific thing because that's the only thing they could do, but observability in general is a much broader topic, and one of the things that was nice about standardization is that we don't have to necessarily be locked in to a single tool or vendor. So this was what I realized is, okay, yes, I can build and run debug locally, but as soon as I get to any other environment where I don't have that visibility into the system, then we need to be able to see inside of it. And so that's what observability is. Observability is simply the ability to observe a system from the outside without having all the details about the inside. So we can see what's going on inside of the system without necessarily having access to the individual running systems and be able to just log into servers and things like that. So this allows us to answer the question of what the heck is going on with our system. What is happening? Something went wrong with the system, or just to even understand like when I click a button, what happens when I click the button? Observability is the thing that enables us to be able to answer that question of what the heck just happened. To get there though, our system needs to emit some data to the outside world, to something that would allow us to be able to understand what has happened at each point in the process, and be able to understand how those different pieces are connected to each other. Now, for me, this makes a lot of sense because my background is not in software development. My background is in electrical engineering. And electrical engineering, we ship things to a customer that's literally inside a physical box, and we can't see what's going inside of there. So we do need those components to emit signals to the outside world to understand, are these components working or not? So I saw this, I'm like, oh right, this is what I was doing, years and years ago when I needed to make sure a system worked, and the only thing I had access to was a port I can connect to from the outside. Telemetry is the way I can understand what the heck is going on behind the scenes. So inside of OpenTelemetry, there's this idea of signals. And signals are the different sort of measurements of telemetry data that we're exposing to, I won't say the outside world, really to something that's going to be collecting that telemetry data. So these different signals include logs, and logs include some sort of text data, which is the message of the log. And they often include a timestamp, and they often include some metadata about the thing. They don't always include all of these, so we'll talk about what to do when they don't have all this sort of information. But this is sort of the baseline I see most folks in their systems, is they have log information there. Now, if I have a complex set of services where I have one service calling another service calling another service, it is really, really hard to understand if I have some sort of action over here that results in some sort of action over here, that those two things are connected to each other. Now, in the olden days, which was 2010, we would try to do this sort of correlation of activities and actions just manually through log messages. But I'm here to tell you, it sucks to try to do that. I've built that system, and I never want to build that ever again. So we need something else that's more appropriate for this kind of information, this kind of data. And so that data is known as traces. Traces are I kind of think of like a much more intelligent, souped-up version of logs, because traces basically take logs to the next level, whereas logs have like a timestamp and have metadata. With a trace, we start to have identification over individual actions or operations that are occurring in our system. So traces contain an identity. That is, I can distinguish between this specific trace or activity versus a different trace or activity. There's an identity built into it, not just a timestamp, because that's not always sufficient. Like we may not have like the exact precision of an individual log message to say, was this the same thing that was happening, whatever. The traces will contain that identity information to be able to absolutely distinguish between these two actions that have been performed here. Traces also include a duration. So they have a start and an end date, a timestamp, as well as like how long that thing took. So that also means that we can also measure how long certain operations take. Trying to go just purely based on log messages, again, like can be, quote, possible, but can be really challenging to understand when did something end. So systems that can only perform or can only collect logging information will try to have these like special log messages that say like this thing ended the operation, and again, they're like in Humpty Dumpty land trying to put the pieces back together again. In traces as well, there's this idea of a graph of operations where I can have a parent operation like a user clicking a button on a screen, and that may result in other sub-operations that are related to the parent operation. So traces also include that concept as well as links to the other, the related operations that you're performing, and a bunch of other junk that I won't go into in a terrible amount of detail, but just to say that you cannot easily build out this hierarchy of calls just purely based on the log details. You want something that's more specialized for that kind of data. Once we start to go further and further out, like broader and broader scope, so next we have is metrics. Metrics are a measurement captured at a specific point in time, but it's not just a duration. Now we can have more interesting kinds of measurements for whatever kind of thing we want to measure. So these are things like, well, how many clicks did I get? How many percentage of things happened? What percentage of things of these happened over time? These are kind of things that we can gather via metrics. There are other telemetry signals, like there's something called baggage, which I won't go into a whole lot, and like vibes, I guess. Like there's just, right now, like the three main ones are logs, traces, and metrics, but this is like, well, you can have other kinds of telemetry data if you want out the other side. So this organization was initially using only Splunk as their sort of base, sort of telemetry collector of data. So all of the logs in the system were being sent to Splunk. But we saw pretty quickly that with this really complex set of services calling each other, that the just pure log-based approach was not sufficient enough for us to understand how different operations were connected together. So we'd have these things of like, okay, the user clicked this button. Let me go to the logs and then like find other operations that happen within that like 5-second time span. And then hopefully I can kind of like figure out, maybe I can see the individual log messages that correlate to that specific operation. So we saw pretty quickly that logs were just not enough for us to be able to answer questions in this more complex system. So we introduced, in this case, Zipkin. Zipkin is dedicated towards collecting and viewing trace information. And I'll be showing these tools as well here in a minute. So we started pumping out trace data to Zipkin to be able to view and find those more complex trace data. And then finally, metrics in this application were all sent out to Datadog. And then after viewing or after looking at the pricing of Datadog, I realized like I am in the wrong industry. I should have gotten into observability tools because, oh my goodness, these things can be quite expensive to be able to get all this stuff out. Now, it can become more complicated than this because you have things like application performance management, like these APM tools that tell you like which pages users visited and things like that. You can get that data from this other information, but a lot of times those APM tools just require a lot more, a lot more modifications and changes. They're answering different questions to different people, but it is possible for you to pick a single observability solution and have that data be pushed out to all the kinds of people that are interested in what the heck is going on with your individual system. So this system started off with just Splunk via logs. And the way that system worked was it would just look at the console out of your application and forward that over to Splunk. So you didn't have to change your application itself. It would just like take console out and spit it out into Splunk. So it's like, well, I guess that's something, I guess. But when we wanted to introduce tracing, we had to make a decision of, well, how the heck am I going to introduce this new kind of telemetry signal into my application? Now, I've had to do this in the past before with other existing systems that did not have any kind of telemetry signals going on. And so I was dreading this new effort to figure out how the heck am I going to introduce tracing amongst all the different kinds of things that I want to be emitting tracing data. So previously, before OpenTelemetry, you'd have this like matrix madness where I would have these different telemetry signals, log, traces, and metrics. And if I wanted to introduce telemetry to one of those things, I had to worry about the different SDKs that were possibly available. We would worry about like, okay, so Zipkin has a fantastic Golang and Node and Ruby and Java and Python and literally everything except C# as a great SDK. So we're like, well, we want to use Zipkin. Do I have to roll my own extensions to my application to be able to handle that? As well as like plugging into all of the different things that we'd want to emit tracing data from. So we were doing RabbitMQ, we were doing Mongo, we were doing SQL calls. Would we have to go and extend each of those different client SDKs to be able to pump out this tracing, these telemetry signals? So this is what I didn't want to get involved with, was yet another custom extension that I would have to maintain. I'm also an open source developer, and I actually don't want to have more open source projects. I want to have fewer because it's such a headache. So I didn't want to have yet another set of libraries that I would be on the hook for forever to be able to maintain against these different things. And that's even just to assume, like, would my client even want to pay for these things? Did the client want to pay for me extending the MongoDB driver for Zipkin? Oh, we went from Zipkin to something else. Okay, now I got to write a new library to be able to handle that sort of thing. That's what I'm trying to avoid. So the promise of OpenTelemetry was to standardize on all of those things, that I could put OpenTelemetry in place and it would be able to handle those different telemetry signals across the different things I would want to instrument and putting them out to other external providers. This was the promise of OpenTelemetry that I saw when I was like, okay, I need to get this tracing data. How do I do so? Now, at the time, I was like, okay, yet another standard. It's probably going to fail, like all standards do, like it's an N+1 sort of thing. But I thought, well, if I'm writing to this SDK versus the custom Mongo one or RabbitMQ, well, I mean, at least it does the job. Maybe it works in the long run, maybe it doesn't, but at least it can work. So this is one of those kind of funny times in my career. I've only had this like maybe 5 times in which I had a really big problem I needed to solve, and then someone had solved it like 2 months prior. Like usually that's not the case. Usually there's some complicated problem and I have to solve it myself or I just give up. But in this case, I needed to solve this problem and like Microsoft said, hey, we're going to invest in this. And so that's what they did. Microsoft, this was 2019, so that was like, what, 2 years ago? 3 years ago? No, COVID has wiped all sense of time from myself. So they were seeing this as well, that people were trying to standardize, and it wasn't just on like one specific format or one specific tool. It was much broader than that, that it was across different kinds of signals, different kinds of information. And they said, hey, we can, instead of having everyone do app insights, which I think they would want anyway, honestly, they said, okay, we'll build this, we'll help contribute to the standard, and we'll directly support this standard inside of .NET Core, which was what, .NET Core 3.0 at the time. I know we're not .NET 10 or 9, almost 10 right now, but at the time we were .NET Core 3.1, and we're thinking, okay, we don't want to write this all ourselves. So what does this look like in the application we were dealing with? So in a sort of brownfield application, what the observability I typically see is usually a very low cardinality of telemetry. And cardinality is just simply the ability to find the right needle in the haystack to say, are there attributes I can put in it to make sure I can find that exact operation the user has performed? Usually there's not that level of like exactness in the data. Usually it's like, okay, what time did you click that button? And then let's go look at the timestamps and go like put a 5-minute window or maybe 30 seconds. Oh, that's not even good enough. 5 seconds to be able to get that exact sort of click going on. So usually it is difficult to find that exact operation that the user's performed. It's almost always only logging. That I just have logs that go out to, I don't know. Does anyone here like logging to disk still on a VM somewhere? Yes. Probably more of you should raise your hands because I know you probably are still doing this sort of thing. So usually it's only logging, right? We were just like, logging.log information, and that's it. It's often in some place that's difficult to access. So I've had cases where I have to remote desktop SSH into a server to be able to get the folder of logs, and oops, the disk is full, so I can't even SSH anymore. So it's often a place that's hard to get to, and almost always there's lots of vendor-specific extensions or things that we've made up over time. So I had to build distributed tracing back in 2008 or 9, and we just had to make everything up. We just made up our own standards. Well, it wasn't even standards. We were just like, how do you even do this in the first place? So usually what I see here is people have kind of made up their own thing over time, and there's no adherence to any standard. It's just what we needed at that specific point in time. So it's like trying to find the needle in a stack of needles, which, by the way, this took me like 2 hours with ChatGPT to get this image. It is hard to get something like this these days. I should have just asked someone for a picture. So why should we care about OpenTelemetry in a brownfield war? Why can't we just use the SDKs that are available to us? Well, there's a few reasons. One is there's a ton of buy-in and support from folks throughout the industry, which means almost certainly the thing you're using already has a NuGet package out there to be able to get that sort of information out of your system. So that just means that it's less investment with your team to be able to get that thing plugged into your system. I also looked at as, I try as much as possible when introducing new dependencies into my system, is this bringing the system forward in time, or is it anchoring them in the past? I mean, obviously there are choices where I don't have the ability to kind of bring them forward, but for something like OpenTelemetry, this is something that like any sort of telemetry, any kind of data like observability platform is going to be supporting OpenTelemetry. So it's just a thing that people are investing in today versus just like locking you into what they're doing right now. It also could be the case where we just don't have a choice. Where if we want to get this kind of information out of our system, the only choice available is for us to use OpenTelemetry. So just use that instead. And then the last big one was just because we're not locking ourselves into a specific vendor, I'm not coding against a specific vendor's tracing library, logging library, whatever you have it enables more choice in the future to be able to change our observability tools. So I know we build abstractions for databases just in case we change our database, which almost never happens. But handshake deals happen all the time in changing observability platforms. We're like, today we're using Datadog, tomorrow we're using App Insights, or whatever marketing manager at Microsoft calls it today. And in the future, there's going to be something else downstream because those decisions are made well away from us as developers. So by building on top of a standard, it makes it a bit easier to get off that path from a specific vendor and choose something else. So this is my OpenTelemetry journey. It may not be yours, and that's okay. I can only talk about the situations that I've encountered. So a lot about the examples we'll be seeing today are just things that I've run into on the projects that I've worked on. So if I break up and try to build a strategy of how am I going to take what they have today into an OpenTelemetry future, I kind of look at it as how would I break this up into individual components and eventually individual sort of user stories, because eventually someone has to work on these individual sets of changes. So how do I break these individual pieces up? So I looked at it as first, there's the things that are running inside my application, and then there's the things that are then collecting that information on the observability server. So I kind of break up the things between the code I own and the code someone else has written to collect all this data. From here, we have basically 3 main steps of how we are able to manage this observability information. We have the step to generate observability data, the telemetry signals itself. When we generate that data inside our application, something has to take that information and push it out to something. So that is the next step, is to export that data. And then finally, on the server side, something has to then collect that information and be able to do something with it. Now, I will say that there's not really a standard, like if I look at the sort of value to my team, there's more value to my teams on the thing on the left than the things on the right, and that's okay. I want to start basically at the application code that my developers are writing first, and then move from there out to the things that still have value, but I need to basically work from the left to the right. So we'll be looking at the generation of logs, the collecting of logs, and then that will be put out to some sort of provider. There is not a standard in terms of an observability application platform. It's not like the OpenTelemetry folks are trying to replace Splunk or replace Datadog or replace App Insights. Instead, they want to make it easier for you to do so. I still think for some of these companies, they would probably prefer no standard, like to just get locked into their one thing. But I think enough folks have like raised their hand and made us think about it. It says, no, we don't want to have yet another vendor-specific API. So some of these companies are a little bit slower and more reluctant to introduce these SDKs, but that's okay. They're there today. So our traces, we want to generate, collect, or generate, export, and collect. We're being exporting into Zipkin. And the same thing with metrics. Now, the OpenTelemetry folks have defined standards for all of these things. Standards for generation, standards for exporting, and then the standards for collecting as well. There are also standards for getting the data back out of the system as well. That one I found much less traction from folks because like data is money, so they want to keep your data inside this walled garden. But not all observability vendors are the same. Some do actually adhere to the standards for getting data out of the system. But again, I was just mainly looking at the problems that I was trying to solve as a developer. So the things on the left are the things that I was most concerned about. Now, these standards are just SDK standards, right? Methods should look like this. Signals should look like that. The wire format should look like this. And so it's also up to each individual platform, .NET, Java, JavaScript, Node, whatever, to be able to implement these standards. So inside of Microsoft in .NET, we'll have different APIs to be able to use to to generate, export, and collect all this information. And to basically break it down on 2 axes, we had the different components, the different sort of the kinds of things I would be doing. And then on the bottom, I have signals, so logging, tracing, and metrics. And then the different kinds of things I'm doing are generations, exporting, and collecting. And on the bottom, I have traces, or logs, traces, and metrics. Now, Microsoft is a little bit different in this space in that they kind of control most of the ecosystem. So they can define all these APIs, and everyone just kind of goes lockstep and does what Microsoft says. So their approach is going to be a little bit different than other systems that I've dealt with. So if you're doing this in JavaScript land and Node land, the different libraries may be a bit different, but that's okay. You kind of use what has been standardized in whatever your platform you're dealing with. So at this point in time, when Microsoft started investing in OpenTelemetry, Microsoft had already defined a standardized logging library. This was the Microsoft.extensions.logging package. So what they have done, though, is massaged that API to start conforming to the standards that the OpenTelemetry folks have defined. How close it matches the standards, honestly, I don't care that much. That's probably for the standards folks to argue about whatever on Discords and Slacks and whatever. I just wanted to make sure that I'm not picking something that is not like the thing that I want to use for OpenTelemetry here. Now for exporting, to export out to something else, Microsoft has specific extensions to take the logging information, and then there's usually some kind of extension for wherever you want to put that data, whether it's to console, to app insights, to whatever. They've defined some exporting library to be able to do so. And then collection is just blank. Like they don't have like a standard way of collecting that information. Now traces are a little bit funny because tracing has actually been around for a very long time. I just didn't know it because it's been, for a long time, it was very tied to Microsoft's App Insights tool, which, I could probably get that information pushed out to other places, but by and large, I saw that the tracing data was very geared towards Microsoft's App Insights. So usually what I see is folks either using like a custom extension, but inside Microsoft Land, instead of them saying we're going to invent an entirely new tracing SDK, they're going to leverage the existing tracing that already exists inside .NET and just, again, massage that to be the API surface area from OpenTelemetry. Now, the downside is that for that one, like none of the names match because this library has been around since .NET 3.5, not .NET Core 3.0, like .NET 3, the old one from like 2007, 2008. So none of the names match, and so you have to just have this sort of translation in your head that when it says this in OpenTelemetry, it maps to this in Microsoft Land. And rather than just completely ditch the entire surface area of the API, they said we're just going to use what we already have and just kind of move it toward the standard. On the exporting side, though, they only had their vendor-specific one. So in this case, when we're looking at exporting, we're going to be pulling off of OpenTelemetry.exporter-based NuGet packages. So if you're looking at a specific package or a specific collector, then we'll have a specific exporter for that collection. Finally, metrics. Metrics did not exist anywhere in .NET. So in this case, they were actually able to create a new package that closely conforms to the standards of OpenTelemetry, which, by the way, they're also on the board of defining the standards, so sometimes things match what they've already built. And so that's what they've done here as well, is they've defined an entirely new package to be able to push out metrics data. But again, for exporting, it's just like pick the thing you're exporting to, and there's going to be a package for you to export to that. Now, I'll get to collections in a little bit, but there is a standard for collecting that information. It's called the OpenTelemetry yes, there's a protocol standard for exporting this or to be able to gather and collect this information. So there are ways for us to export out into a single common format and then have a collector that then actually abstracts that exporting out to other things, which I'll be showing here in my last demo. Now, one of the things that's great about Microsoft Land is they support things almost forever. Maybe not on like modern .NET 6, 7, 8, 9, 10 sort of things, but in terms of the .NET framework, this stuff is supported for, I don't know, forever? 2050 or something? Heat death of the universe? I don't know. So one of the nice things is all of these packages are supported on every version of .NET Framework and .NET Core, except for like really, really old stuff, which, just get off of that anyway. So that means as well that if I've got existing systems, existing applications, I'm able to pull in these these new versions of packages, and they'll still work. They're supported. They work for us. So my goal was basically to start from the left and then move to the right, migrating away from their existing custom jank stuff they've got going on, and replace each of these in turn with OpenTelemetry until it's all been migrated over, and we're all in this OpenTelemetry utopia land. So we'll look at each of these signals and components one by one, starting with logging. So a logging current state is on the generation side. You maybe have no logging, but that's rare, right? Usually there's some kind of logging. If someone has pushed a system out to production, it probably does something in terms of logging, but almost always it's some specific third-party library to do that logging. Whether it's Log4net or Inlog or Serialog or whatever, it's almost always using some third-party library. Maybe they're using Microsoft Extensions Logging. So if you're in modern .NET, then it's just using Microsoft Extensions Logging by default. But it may just not be in the kind of OpenTelemetry standard format. Or you've got your own like custom abstraction, right? Does someone here have like a logging class that wraps Log4Net? Yes. That's where most of my companies are as well. They've like in an existing system, especially in .NET Framework, that they've got their own abstraction just in case they need to replace it. Exporting. So usually it's an extension to that third-party library. So if you're using Log4Net, there are going to be custom packages for Log4Net to export that information out. And usually it's like in some junk format anyway, right? It's like just out the files or whatever. And on the collection side, oftentimes I see log aggregation, which is basically just looking at I'm spitting log messages out to console.out, and then something is reading that console out and then exporting the logs out to something else. All right, so let's look at an example here of a old application using some old ways of doing logging, and how can we introduce OpenTelemetry to that application. We'll wait for parallels to get a grip. I'm using Windows on a Mac, so I'm sure it'll go fantastically. Okay, let me bump it up a little bit. I don't think that's quite big enough for the folks in the back. There we go. Is that big enough for the folks in the back? Yes, okay. Well, that's as big as I'm going to go here. All right, so this is a .NET 4.7.2 application, so it's still supported, but it's on the the old .NET stuff that I hope I never see again, but just like is still following me around wherever I go. And in this one, if I look at the dependencies, I can see that it's using Log4Net in some old version. Okay, we'll get to the other packages here in a second of what we can pull in to make this work. But it's just right now it's just using Log4Net as is. So in my application, it just runs like a console, whatever. So it just logs out to the screen here. Everything is awesome. Yes, except using .NET Framework, so probably not. And so this is just output, standard output from Log4Net. So what is this actually doing behind the scenes? I've got a awesome service class that does logger.info, everything is awesome. What is logger? Well, logger is that fun custom wrapper around Log4Net. So if I go look at this one, it is wrapping all of Log4Net underneath the cover. So it is doing, and this took me a while to do this demo, so I hope you clap at the end. I forgot how to do all this Log4Net junk. I had flushed it out of my head, and I had to bring it back again for this demo. So this is using this thing of like, oh gosh, log manage get repository. I don't even know what that means. I'm getting this Log4Net config file that's this junk, and I forgot all of this stuff, and I just never want to see it ever again. And it's also got just building up all this logging information. So I have to make a decision here, though, of how do I get this current application, this current system that is just doing this sort of manual logging via Log4Net, how do I migrate it over to using OpenTelemetry? So the first thing I'm going to do is replace every single usage of Log4Net. Well, no, that's not true, because that's going to take a long time. I want to have these small incremental steps. So I want to have a series of steps where if something goes wrong, it's not a big undo to go back to where I was before. I want to work in these very small incremental shippable steps to make it verifiable as we go as well. So the first thing I'll do is pull in a few Nuje packages. So the Microsoft standard for logging and OpenTelemetry is Microsoft Extension Logging. So we need to pull that in here. So that's this package here, Microsoft Extensions Logging. And then we're also pulling in a bridge between Log4Net and Microsoft Extensions Logging. Now, the reason why I'm doing this is I want to have a way to easily kind of transition from the existing logging features and logging customizations that have been done to something else. So having this sort of bridge between the two makes it quite a bit easier for me to have that sort of transition. So here I am pulling in this bridge between Microsoft Extensions Logging and Log4Net. Those kind of bridges also exist for Serialog and Nlog and Log4Net, and those are the only three I can remember about non-Microsoft extensions logging. But if you've got some NuGet package that does logging, there's probably someone out there that has built a bridge between your logging and Microsoft extensions logging. The other stuff is just like comes along for the ride, but those are the three kind of important ones: is the logging abstractions and the logging bridge to Microsoft extensions logging from Log4Net. So the first thing I'll do here is build this bridge between, oh gosh, Control KU. There we go. I forgot how to do uncomment and even here. Between the Microsoft extension logging and Log4Net. So this logger factory here is Microsoft extensions logging. This is the OpenTelemetry logging kind of setup standard here. And here I'm saying, go ahead and add Log4Net via this Log4Net config. So this is basically doing exactly what I was doing before here, except it is doing it inside of here. And then finally, I have this inner logger. So rather than changing all of my code to not use this custom wrapper class, I want to have an easy transition between that. So instead of calling out to this custom Log4Net interface, instead of what I'll do is wrap the underlying logger from the Microsoft extensions logging. This is the logging standard here, and that's what's going to be used instead. So these places now where I'm going to, like, instead of me logging out into Log4Net, I will instead log out to, there we go. I will instead wrap the logger, because it's already wrapped anyway, over to the Microsoft extensions logging that still calls out into Log4Net. So what does this look like? Does it still actually work? Let's see. Oh, okay. So I replaced the usage of direct Log4Net with the usage of Microsoft extension logging. And then what I'd probably do from here is find usages of using these wrapper methods and then slowly replace those over time with just using Microsoft extensions logging directly instead. So instead of me going out to this Log4Net wrapper, I'm just directly using the logging APIs as is. Eventually, I would also remove Log4Net altogether, because once I remove all usages of Log4Net directly for emitting information, once that's complete, there's no more references of Log4Net except for inside this class. Then I can effectively remove that class, providing I can convert this Log4Net config over to whatever it means to set up the logging for this logger factory there. I won't go through all those steps because I didn't set it up in my demo, and it can be left as an exercise for the reader or whatever. All right. So most of my clients that are using are in legacy framework, Microsoft framework, or .NET framework, whatever. They have something like this. There's some wrapper class that is logging, and it's actually using Log4Net under the scenes. But by going this approach, where I'm bridging Log4Net to Microsoft extensions logging, it makes it possible to incrementally migrate from direct usage of Log4Net over to Microsoft extensions logging, which will then almost certainly have ways for you to export those logs out to the providers that you want to. All right, so let's go back to our presentation. So that was logging. Not that exciting, not that interesting, but like most of my customers that are not doing any kind of OpenTelemetry, that's where they're at today. Next, let's look at tracing. Tracing is much rarer, I've seen, in user code. So usually there's no like custom code people have done to generate tracing. Sometimes I may have done something like, I need to extend Microsoft App Insights to do some custom tracing or whatever. So there's almost always no direct user code. Sometimes there is extension code, so I am adding additional attributes to tracing data for App Insights, like I want to put the user ID or whatever. Sometimes there's that kind of code. Almost certainly there's going to be some dependency on that tracing provider, and maybe there's some kind of alternate or custom standard for distributed tracing as well. On the exporting side, there's almost certainly extensions specific to that individual dependency or server. So I've got a reference in my application to exporting those traces out to Microsoft App Insights. And then finally, on the collection side, there's going to be APIs specific to that trace context and the individual server. Now, this is the first kind of example we need to worry about not just one application, but a series of applications, because in order to be able to achieve a complete picture of a distributed trace, we need to have the ability to connect an operation on a server over here to an operation on a server over there. And the way folks have done this is be able to, every time I have a call from server A to server B, is to include some kind of correlation information in all of those calls. And so the standard that was in place basically before OpenTelemetry came around, it was either you rolled your own, which congratulations, like 8 people in the world have done that, or you're using some other distributed tracing tool like Zipkin, like App Insights, like whatever, that have invented, well, not invented, but defined their own standard. Now, Zipkin does have a standard. It's called B3 propagation. So that is a standard, but that's like the N-1 standard. We're going to be on the N+1 standard. And so we'll have to make sure that we can be able to handle the different kind of tracing, the different tracing headers. So you may have to do things to be able to ensure that both kinds of formats are propagated across. So the new standard is ratified by the W3C, so it's not just a vendor or a series of vendors. It is like W3C level. They defined a standard for the tracing Humpty Dumpty information to connect different operations and different servers, and this is known as the trace context standard. This used to be something that you had to turn on in your applications, but starting with like .NET 6-ish or 8-ish, it's just turned on by default. However, the receiving side on receiving incoming calls is resilient to whatever standard they detect in your header. So if you're using an older standard, it'll say, oh, okay, you're using that standard, then I'll default to whatever this is. And so it's basically kind of a feature toggle, a feature detection on which standard you're actually using here. All right, so let's go look at an example. So this example is more complicated than a console application because we're talking about distributed traces. And so in this example, I've got a more complicated application and system going on. So this one, I've got a web application that receives API calls. It talks to databases. It calls other APIs. It sends out messages. It's not doing anything like business or domain specific, but it is like a complicated set of applications and systems connected together. Now, one of the things that Microsoft has also done when, in terms of making it easier to build these kinds of systems, they've also enabled it, made it easier to kind of turn on these kinds of signals in all of our different applications through their Aspire project. Now, this is not an advertising for Aspire. I'm using Aspire because it makes it 8,000 times easier to introduce these concepts and all these different applications, and also just to launch this thing all together. One of the things you can do with Aspire is, I know they're have all this distributed system madness, but one of the things you can do is you can add what's known as a service defaults project. So this is, I'm using JetBrains Writer, but it's a .NET template where you can say, I want to add a service defaults. One of the things that is happening in the service defaults project is default setup configuration for OpenTelemetry. So in modern .NET applications with no observability, I'll first add a service defaults project because that's basically all the services.blah to add all of the OpenTelemetry magic behind the scenes. It's not magic, but this at least gives me like, here's the kind of standard setup for OpenTelemetry. So I've already done that. I've added a new service defaults project here, and we're going to walk through what's going on behind the scenes as well. There's also the app host, which will launch all your applications. You don't have to use that thing. This is just a shared library that includes common setup for running applications. That's all that is. So I've turned all that off, but inside of here, you have, it basically just creates this extension method that says add service defaults. So inside of my applications, I've modified it to blah, 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 do the thing, and then builder.add service defaults. So that's just an extension method to add some sort of common OpenTelemetry configuration. So let's run this and see what observability we have today, which is none. All right, so this is my actual running application. It's just Swagger, of course, so I should probably change this to, what's the new hotness? Something else, I think. So hello CPH, execute. And so behind the scenes, what that's doing is it hits an API. That API tries to make the most complicated distributed system, like puzzle pieces together that I could think of at the time. So that one calls an API, it calls RabbitMQ, the RabbitMQ messages then like talk to databases, one talks to Mongo, one talks to SQL, but I would not see any of that because over here I have the Aspire dashboard. That's another really awesome thing I do with my customers using like more complex distributed systems is Aspire also lets me see this like this view of all my services and then all the telemetry data as well. The Aspire dashboard is a collector of OpenTelemetry data, and it also lets you view it as well. So it's the best OpenTelemetry dashboard you'll ever see, except you can't deploy it to production. So I go like here, and there's no logs, there's no traces, and there's no metrics at all. The only thing I have is console logs. So if I pick one thing, like my web application, this is what we're starting with. Just straight up console.writeline, or I mean it's like logger.blah, but it's just spitting out all of my console, all my log information just to the console. It's not spitting it out into any standard format. So let's fix that. So back over in my application, let me go and stop it all. Edit and continue is not yet in Inspire. That would be really cool, but it's not there yet. I have to stop it and start it every single time. So the first thing I'm going to do is back in my service defaults, I'm going to enable OpenTelemetry logging. So in this application builder, this add service defaults, there's this configure OpenTelemetry. When you create this service defaults project, all it's doing is just spitting out this like code here. You can just copy paste the code into your application. I just do file new service defaults and be like, what is the latest, greatest way of doing this? And then copy the code over. But all it is just a series of like extension methods plus a series of NuGet packages. So we have our OpenTelemetry stuff here, OpenTelemetry.extensions.hosting. We have the instrumentation of listening to specific instrumentation from different sources, and then exporting out to these different providers here. So I'm going to uncomment out. The logging portion. I'm going to uncomment out the tracing portion, and we'll walk through what this is doing behind the scenes. So when I'm doing this, the logging component here, yes, I have like the extensions to logging, but what this is doing now is redirecting that logging into the OpenTelemetry sort of pipeline so that they can all be standardized in terms of exporting and collecting all that data. So that's what this. That's why I would put this logging piece in here. I'm also going to include the tracing information. And the tracing information has a few pieces here. The first is I need to, by default, when something emits some kind of trace data, it's not collected or listened to by default. So each of these sort of add are lighting up, listening to specific tracing data so that it can all be collected behind the scenes. So I'm saying I want to collect ASP.NET Core, so that's incoming server requests. Then I have outgoing gRPC requests, which there are none, but who cares? There's outgoing HTTP client requests. There's Entity Framework as well, so all the SQL calls, I'll have that as well. Sometimes I have configuration, so I can say, hey, also include the SQL statement as part of that. Maybe you turn that off in other environments for security purposes or whatever. It won't collect the parameter data, so you find it very quickly if you're open to SQL injection, if you start to see like the parameters inside your traces there. And then any other source, typically what providers will do is they will document to say, my source name is called this, and if you want all the different tracing sources that I emit, then you can use a wildcard mapping to say .star to get all that as well. So in Service Bus, I'm using that for messaging. We'll collect and export all of the trace data based on using that. And then this one, I'm using MongoDB. So this is the name of that source to be able to collect the tracing data from Mongo. So let's run this again. And, oh wait, there was one other thing I needed to do in each of the different projects, I think. Stop it. Yes, we need to, let me stop real quick. I need to enable it. Some third-party providers also need additional setup to enable OpenTelemetry for those individual components. So in Service Bus has this, it just depends on the documentation for what you want. Typically, this is pulled out into some common library. And I want to enable, it's already turned on. Add client, and I want to not disable tracing. False. So yes, now it's enabled. Tracing is going to be happening here. We'll do the same thing with our web application. I think that's all I had to do here. And in our service applications to turn those back on as well. So I've got enable OpenTelemetry. There we go. OK. So again, depending on your third-party libraries, they may require additional configuration to light up and start performing OpenTelemetry generation of telemetry data. So it just kind of depends on the libraries you're using. But basically, with tracing, anything that crosses a process boundary or does I/O are things you'd want that tracing data as part of it. So you can distinguish like, I talked to a file system. I talked to an API. I talked to a database. You want those to all show up in your tracing data. So let's go ahead and try this out. Hello, not Jello. Hello, CPH. Execute. OK, now in my Aspire dashboard, of course, we had the console that was doing stuff. So this is exactly what it was showing before. It was like, yeah, there's something going on here. But now when I go over to my log data, now I have those structured logs, which can contain now more interesting information that was just text on a screen. With OpenTelemetry log data, we now have individual attributes of what was going on. This is much richer than the just text data we had before. It's now including more interesting information about like, what was the server name, the instance, the language, context, all this sort of stuff. But now I can also go to traces. So when I hit that one API to generate all that information, that actually generated this crazy trace calling all these different services, doing all these different things. So by me turning on OpenTelemetry and then having it just running inside of Aspire, Aspire will automatically collect and display this tracing information. So I can see like, hey, this did some SQL stuff over here. What was the SQL it did? Oh, there it is. And it was related to this specific individual call. I wish that I could use something as pretty as this, like in my actual cloud environments, but I have not yet found anything that is as nice as it is to use Aspire locally. So you do see like GitHub issues of like, hey, can we please have this running in a server environment? This is all running in process in memory. As soon as you close the app, it all goes away. But that's OK. OK. So this is just exporting its generation and exporting of data just to Aspire. But if I want to export out to a specific collector, in this case, I want to export that out to Zipkin. In that case, what I'll do is I will reference a specific package reference. So you see here, I'm going to export out to Zipkin. And then in my extensions, I have down here exporting. There we go, enable Zipkin exporter. So this will export directly to the OpenTelemetry collector. And this is, none of my application code has to change whatsoever in order to do this. When I uncomment this line, now the tracing data not only gets exported out to Aspire, it will also export out to Zipkin, which I've also included as one of the Aspire components as part of running my application. So over here, in my app host for Aspire, I have added Zipkin, which is just running as a Docker container that is just out there listening for tracing information. So I'll do this again, whatever, hit execute. And then now, of course, I can see the traces here inside of the Aspire dashboard. But if I go look at the resources, I see that, hey, down here I've got Zipkin. So if I launch up the Zipkin UI and just say run query, here is that exact same set of traces that now show up inside of Zipkin. Well, actually it shows both inside of Zipkin and inside of the Aspire dashboard, just by me adding that one little line of code inside the service defaults, which was just to say, export this stuff directly instead of using the OpenTelemetry collector. Now, there are going to be cases in which we don't have tracing data. There's not some third-party package we can use to be able to include tracing data. And so for those cases, we want to emit our own tracing information. So one example that I ran into was hosted services. So inside of my program CS for the web application, I have a hosted service. In this case, it's a hosted service to initialize the database. So this is the thing to run my entity framework migrations on application startup. That thing has no tracing associated with it whatsoever. However, I can introduce that to my application using the standard APIs from Microsoft. So instead of me using a Zipkin API or an App Insights API, I can instead use the APIs from Microsoft. This is just the standard diagnostic source API. And so I create an activity source with a specific name. And then inside of the work I want to measure to see what it does, I can then start the activity and then record the activity if it completes. But then it'll just kind of auto-complete with this when this is done. Now, the last thing I need is this activity has a name. So over in my service defaults, I will extend this to include an additional source. Whoops. Yep, there we go. To include the migration's source of tracing data. And now when I run this, I'll see an additional trace span show up for executing my database migrations. So I don't even have to interact with the Swagger UI. I can go over here to my traces, and here I see, let's see, this is going to be the web project. Aha, there we have, migrating database. So this is the work to actually migrate the database. If I didn't have that tracing information set up as an activity source, none of this would show up as like an operation that was getting performed. By adding this activity source, I can gather all of these different operations together and saying, hey, when I migrate the database, this message right here, that is this message right here. And instead of just me using log messages to say this thing happened, I'm gathering all these things together into a single identifiable activity with a start and an end. And so now that will show up in my system. All right, so I want to wind things up here. Metrics are going to be a very similar kind of concept. I will add the sources, I will add the collections, and now they'll be exported. So it's basically just doing the same thing that we did there before. So one of the things I like to do here is provide exit ramps as I'm doing this architectural migration, that at any point in time I can stop what I'm doing and say this is good enough. So that's what I see here, is that in your OpenTelemetry journey, you can start with each sort of component in the process, generation, exporting, collecting. And then for each signal, you can potentially have an exit ramp to get you off of and be able to exit out and say, this is good enough for where we are today. If you have questions, I'll be hanging around afterwards. Otherwise, good luck on your OpenTelemetry journey. It is not something just for greenfield projects. You can use it on existing applications as well. And it helps you avoid that terrible vendor lock-in. Thank you all very much. It's like almost the end, right? We're like almost at the end here. So thank you all very much. I hope you have a great rest of the conference.